Sending a PDF directly to Claude takes 13.8 seconds per file. I measured it across 1,200 real invoices. If you're building a SaaS where customers upload documents and wait for a result, that's not a benchmark number, that's a churn number. Every tutorial out there optimizes for extraction accuracy. Nobody tells you the same Claude fed the same invoice a different way. Runs in 2.1 seconds with identical field accuracy. I'm Lazar. I ship document automation to paying small businesses every week, and the latency complaints came from real users. Let me show you the exact fix. Here's the scenario you probably recognize. You built a tool that takes a PDF from your customer, sends it to Claude, and pulls structured data out. Things like invoice number, vendor, line items, totals. The accuracy is great. You tested it on 20 files. It nailed 19. You shipped it. Then real customers start using it, and the support tickets come in. Not about wrong data, about the spinner. They upload an invoice. The screen freezes for 14 seconds. They refresh the page. They upload again. Now you've got duplicate processing and an angry user. We hit this exact wall on a client project doing invoicing automation for small businesses in the Balkans. The owner forwarded me a loom of his own customer, rage-clicking the upload button. So I sat down and measured what was actually happening. Direct PDF upload to Claude Sonnet. Averaged over 1,200 real invoices, 13.8 seconds per file. That's wall clock, from request sent to JSON return. The same Sonnet model, same prompt, but fed a rendered PNG of page 1 instead of the raw PDF, 2.1 seconds. Same accuracy on every field we care about: invoice number, date, vendor tax ID, totals, line items, 6.5 times faster. Now you might be thinking, why not just extract the text with a library and skip Claude Vision entirely? We tried. PyPDF2, PDF Plumber, the usual suspects. 0.9 seconds, beautifully fast, and 71% accurate. Scanned invoices die. Multi-column layouts die. Anything with a logo on top of text dies. So text extraction is off the table for any pipeline that touches real-world documents. The winning architecture is render the PDF to an image yourself, then send that image to Claude. Here's why it's faster. When you upload a PDF directly through the Anthropic API, Claude's backend has to ingest it, rasterize every page, run its own layout pass, and then feed pages into the vision model. You're paying for all of that on the request thread. When you pre-render the page yourself, you do that work once. You control the resolution, and Claude only sees a clean image. Let me walk you through the code. The whole thing is about 15 lines of Python. You need PDF2 image, which wraps Poplar, and the standard Anthropic SDK. Step 1. Convert the PDF to images with PDF2 images. Convert undersky from undersky path. Pointing at your file and setting dpi to 200. For most invoices, page 1 has everything you need, so you grab images at index 0. Step 2. Resize. This is the part most people skip, and it costs them money and latency. Claude's vision model has a maximum useful resolution around 1568 pixels on the long edge. Anything bigger gets downsampled on their end, and you pay to send the extra bytes. So use Pillow to resize the image to 1568 pixels wide, keeping aspect ratio. Step 3. Encode it to base 64 and stuff it into the message's payload with type image, source type, base 64, media type image/PNG. Step 4. The prompt. This is where you lock the output. Don't ask Claude to extract the invoice. Give it a JSON schema in the prompt itself. List every field name, the expected type, and one sentence on what it means. And the prompt with return only valid JSON. No prose, no markdown fences. That alone cuts another half second because Claude stops generating explanatory text you throw away anyway. Step 5. Pass the response. Wrap it in a try, except around JSON.loads. Loads log the raw output if it fails so you can debug, and you're done. On a one-page invoice, the full round trip, including network, vision inference, and JSON parsing lands around 2 seconds on Sonnet. Now the demo. In the client dashboard, we put a stopwatch next to the upload button, just so I could screen record the difference. Before the change, customer uploads a vendor invoice. The spinner runs. 14 seconds. JSON appears in the table. After the change, same invoice, same model. The spinner barely registers. The row populates almost instantly. Same accuracy. If you're building a customer-facing tool that processes documents, latency is a product feature, not an afterthought. You can see real automation pipelines we ship for clients, including the full PDF to JSON code and prompt template from this video at BizflowAI.io. Hit subscribe and ring the bell so the next breakdown lands in your feed. And if you've got a document workflow eating hours every week, book a free 30-minute discovery call at BizflowAI, and we'll map out what to automate first.